Hello dear student, our topic is today dot and cross diagram. Basically we have two types of dot and cross diagrams. One is for ionic bonds and another is for covalent bonds. With the dot and cross diagrams we just show their bondings. Basically we don't get any difference between electron of a substance and electron of other substances, but still we show here electrons as dots of an atom and electrons as cross of another atom. This is just to study them clearly. I'm going to start with some examples. Let's start with two examples. One is for ionic bonds and another is for covalent bonds. The most common for ionic bonds is sodium chloride. Let's draw the dot and cross diagram of sodium chloride first. This is sodium chloride. NaCl is the formula of sodium chloride, and its dot and cross diagram I'm drawing here. Consider this is sodium, and 1, 2, 3, 4, 5, 6, 7, 8. I'm giving 8 dots as 8 electrons in its outermost shell. Here we are going to draw only outermost shell electrons. Here this got 8 electrons in its outermost shell after losing an electron, so we are giving here +1 charge. And another is chlorine. Here is chlorine. Chlorine 1, 2, 3, 4, 5, 6, 7. 7 electrons of chlorine. We are showing them as cross. And here's 1 which is from sodium. So this is a minus chloride. And now we see the dot and cross diagram for covalent bonds. I show you the simplest one, which is hydrogen chloride. Here is hydrogen, and this is hydrogen atom, and this is a little bigger chlorine atoms. Hydrogen is dot and chlorine is cross. Chlorine has more electrons. Here is dot and cross diagram. If you look at their dot and cross diagrams, this is an example of ionic compound and this is an example of covalent compound. We see clearly they are different. Here we see these two atoms overlap and they share electrons, and here we see the electrons being transferred. After transferring electrons, they form ions. These ionic compounds form ions and covalent compounds forms molecules. If the compound you have an ionic compound, certainly you draw dot and cross diagram of this type, but if the compound or substances have covalent, you will certainly draw this type. So first decide, look at the compound, look at the substance carefully to understand whether the compound is ionic or covalent. And how to know this? Now you look at this compound, sodium chloride, an ionic compound. How do you know this compound is ionic compound? Here the first is sodium, which is a metal, and chlorine is a non-metal. If you get your compound with a metal and a non-metal, that is certainly an ionic compound, and you will draw this type. On the other hand, if you have a compound or a substance consists of both of them are non-metals, no metal is there, then your bond is certainly covalent and you will draw this type. And when your compound consists of a metal and non-metal, non-metal means an element with more than 3 electrons in the outermost shell. So when you get compound consists of metal and non-metal together, then this is certainly ionic compound. So this is the electron configuration sodium. From this electron configuration, we clearly understand that this is a metal because just 1 electron is in its outer shell. And chlorine is also there. Chlorine's electron configuration is 287. What do you get? 7 electrons in the outermost shell, which means that metal will lose its electrons, and this electrons moves to chlorine. And here you get electron configuration of sodium changes as 28, and there is another change of sodium, which is it forms +1 charge after losing an electron. Same for chlorine. Chlorine forms chloride ions. When this gains an electrons, we get electron configuration 288 now. So in our dot and cross diagram, we are showing here 8 electrons in the outer shell, and here also 8 electrons in the outer shell. Look carefully. Here all the electrons are given as cross, but 1 given as dot, because this has been from sodium ion. So when you show this, there's anion. Anion should have always 2 types of electrons, one cross, another dot. Dots, maybe you consider that electrons coming from the metal. So this is sodium chloride. Now I show you another example, which could be magnesium oxide. This is certainly another ionic compound. Why? Because magnesium. Look, I draw the electron configuration first of magnesium, which you get 2, 8, 2. How many electrons do you get in the outer shell? Only 2. Only 2 means this is a metal. And here the oxide, atomic number 8, we get electron configuration 2, 6. Look, outer shell 6 electrons. This is a non-metal. So this bond also consists of a metal and non-metal, and certainly ionic. So here I am going to draw first the atoms. Only I draw the outer shell electrons. Here I am giving 2 electrons as outermost electrons of magnesium. Here is magnesium, and then oxide. Oxide having 6 electrons. I am giving 6 as cross. So I am going to show you how they transfer electrons. These 2 electrons being transferred to this oxygen atoms. When magnesium loses its outer shell electron, when these 2 are not there, then its inner shell appears, which is inner shell magnesium 8 electrons. So here's one change to magnesium. Another change also there is forms 2 plus after losing 2 electrons. And look at oxygen. Oxygen here gaining 2 electrons. Let's draw oxygen. Here's oxygen. This was already having 6 electrons, and I am giving 2 more. These 2 are dots. These 2 are dots means these 2 are coming from magnesium. Here you get 2 changes of oxygen. One full outer shell. This was 6, now is 8. Another change is 2 minus. So when we draw this is magnesium, and this is oxygen. Now we call magnesium ion and oxide ion. These 2 are basically dot and cross diagram. These 2 are the atoms of magnesium and oxygen before they bond, and these 2 after the bond. After the bond they form ions. So this is dot and cross diagram of magnesium oxide. I'm going to show you another example, which is magnesium chloride. Magnesium chloride. And this bond is also ionic because the magnesium is metal and chlorine is non-metal. So here's a puzzle. Magnesium loses 2. Magnesium needs to lose 2 electrons to be stable, and for chlorine it needs to gain 1. So it cannot gain 2 electrons given by 1 magnesium atoms. So what's the solution? The solution is very simple. It's clear. So we write the formula. Look at the formula. You understand why this happens. Why we write MgCl2. Why 2 is there? I mean 2 chlorine atoms with 1 magnesium atom. This is because magnesium loses 2 electrons, and you need 2 chlorine atoms to gain those 2 electrons. It gains 1. So we need 2 chlorine atoms. Let's first draw the atoms. Here is magnesium, 2 electrons in the outer shell. We just show here outer shell, and chlorine 1, 2, 3, 4, 5, 6, and 7. When this magnesium donating 1 electron to this chlorine is already satisfied. It cannot gain the other electron of magnesium. So what we're going to do, we draw another chlorine atom. So we need another chlorine atoms to gain the other electrons of magnesium. So electron configuration of this chlorine also same, which is 7 electrons in the outer shell, 7 like this. This comes here, and this is why magnesium needs 2 chlorine to gain those 2 electrons. These 3 atoms you see before the bond, and after the bond what we draw, that is their dot and cross diagram. Let's see, I draw again magnesium. This magnesium is after it loses 2 electrons. So when this loses 2 electrons, its second shell, its inner shell appears with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And here you get a change of magnesium. It's now having 8 electrons. Also having another changes, this will have 2 plus charge because it loses 2 electrons. And now about chloride. Chlorine was having 7 electrons. 1, 2, 3, 4, 5, 6, and 7. So now after it gains 1 electron, this is 1 dot which is coming from magnesium. Altogether this will be minus 1 and chloride. So this is minus chloride. So magnesium 2 plus and chloride minus 1. So certainly you have 2 chlorides side by side, 2 chlorides together gaining the electrons of magnesium. So I give here 2. You can also draw 2 chlorides side by side, or you can just give here 2. So this is magnesium chloride. So this is how we draw a dot and cross diagram of ionic compound. Normally we get the students making mistakes because they start drawing dot and cross diagram without having the electron configuration. So first they need to write the electron configuration, and they will decide whether the bond is ionic or covalent, or how many electrons the atoms lose or gain or share. Okay, so first write electron configuration, then you start drawing your dot and cross diagram. These are all very simple, very easy. So now I'm going to show you how to draw dot and cross diagram of covalent substances. First you need to decide that your bond is covalent. That you can get when metal is absent there. Both the atoms are non-metallic atoms, then you decide the bond would be certainly covalent. They will share electrons. And how to know this? Electron configuration. First you write the electron configuration of the atoms. Here you get hydrogen, only one electron, and chlorine 287. So see the electrons which indicate both of them are non-metal atoms. So they will share electrons because none of them is ready to lose electrons. Here is hydrogen, I draw again hydrogen, and here is chlorine. Hydrogen is going to donate 1 electron for sharing in the common space. Chlorine is also going to donate 1 electron for sharing in the common space. And another thing, here you get 7 electrons in the outermost shell of chlorine. 1 of them is donated here and 6 left. And normally many students forget to give these 6 electrons. That is also part of the dot and cross diagram. You mustn't forget this. So here I am giving these 6 electrons which are left behind as lone pair. So here you get dot and cross diagram of hydrogen chloride. We say this pair being shared as bond pair, and this pair 1, 2, 3 more pair of electrons, we call them lone pair of electrons. Then you see some more examples. Here is a hydrogen atom, here is another hydrogen atom, both are non-metal. The electron configuration of hydrogen is that you first write 1, so this donates 1 and this also donates 1. So this is dot and cross diagram of hydrogen. Here you see just 1 electrons of hydrogen, this is given in the common space, so none of them having any more electrons. And then if we write O2, dot and cross diagram for O2, let's see first electron configuration of oxygen, which is 2, 6. And this is oxygen atom, this is another oxygen atom, these 2 oxygen atoms overlap and then ready to make bond to share the electrons. So how many? Here you see oxygen having 6 electrons in its outer shell. This is why oxygen sends 2 electrons for sharing. This oxygen sends 2 electrons, this we write as 2 dot, and another oxygen I'm giving 2 crosses because both the oxygen both are doing the same thing. One more thing left here. Here we got 6 electrons, so we decide 2 being donated, 2 being given in common space for sharing. And another thing, after 2 gone, out of 6, 2 gone, still 4 left. There's 4 electrons you must show. Yes. And this is also another oxygen and 4 electrons. This you get. Here you get hydrogen bonds with another hydrogen atoms making 1 bond. I can show you this bond because here you get only 1 pair of electrons. And here between 2 oxygen atoms we get 2 pair of electrons. So we give here 2 lines, 2 bonds. Now I'm going to show another. This is nitrogen. Nitrogen electron configuration is 2, 5. So here you see 5 electrons in the outermost shell. I draw a nitrogen atom. I draw another nitrogen atom. These 2 nitrogen atoms. And this nitrogen atom sends 3 for sharing, 3 dots, 1, 2 and 3. 3 dots, and out of 5, 3 gone in the common space and 2 is still left. Look carefully, nitrogen is having 5 electrons in the outer shell, 3 of them given in the middle for sharing with another atom, and 2 left, 2 dot, 2 left, as we call them lone pair of electrons. This is another nitrogen. This also sends 3 electrons for sharing in the common space, and out of 5, if 3 gone, still 2 left. So this is dot and cross diagram of nitrogen atoms. We can show 3 bonds, triple bonds between nitrogen atoms. Before you draw dot and cross diagram of covalent substances, you need to be sure about 2 things. 1, how many electrons does an atom send for sharing? 2, after sending that number of electrons, how many still you have? First you write electron configuration. You get hydrogen having 1 electron, so it needs 1 more for completing its outer shell. So hydrogen sends 1 for sharing. For oxygen, look at the electron configuration. It needs 2 more electrons for sharing. This is why oxygen sends 2 electrons in the middle for sharing, because it needs 2. And for nitrogen, look at the electron configuration. What? You get 5. So nitrogen needs 3 more electrons, so it's gonna send 3 electrons in the common space for sharing. This is why we get hydrogen sends 1, because it needs 1. Oxygen needs 2, so oxygen sends 2 for sharing, and nitrogen needs 3 to complete its outer shell, so it's gonna send for 3 electrons. And now the last point, how many electrons remains as lone pair after sending the certain number of electrons they decided to send for sharing. Here was 6 and 2 gone for sharing. How many left? Certainly 4. That 4 we are giving as lone pair, 2 and 2, 4. Here's also 2 and 2, 4. After 5, 3 gone in the common space. How many left? Certainly 2. So we are giving 2 electrons as lone pair, and for this 2 as a lone pair. So now let's say the dot and cross diagram of covalent bond between 2 different atoms. I write water. Here you see hydrogen bonds with oxygen. Dot and cross diagram, hydrogen for 1 and oxygen 2, 6. So let's draw oxygen, hydrogen. Here you see hydrogen has 1 electron. 1 is here, 1 is here, given in the common space for sharing. And oxygen 6 in the outer shell. Out of 6, it needs 2 more electrons. So accordingly, oxygen is going to send these 2 electrons for sharing. So this 2 with one with this hydrogen, another with this hydrogen. Look carefully, as this needs 2 electrons, it sent 2 electrons for sharing. And out of 6, 2 gone already for sharing, and how many left? 4 electrons. This 4 we are giving as lone pair of electrons. Now look at this. This is water. And another is ammonia. Look at this ammonia. Here I give the electron configuration 2, 5 for nitrogen. I draw ammonia, nitrogen here, hydrogen, and another hydrogen. So look carefully, hydrogen 1 electron, so 1 given in the common space, hydrogen 1 in the common space, and nitrogen was having 5, 3 short, so 3 to be given with hydrogen for sharing. And after 3 gone, how many left? 2 left. So this is dot and cross diagram for ammonia. And I'm going to show you the last one for today. This is NCl3, we call nitrogen trichloride. Here we get nitrogen as 2, 5, 3 short. Here is chlorine 2, 8, 7, 1 short. I draw nitrogen first. Here is chlorine, and here is another chlorine atom. So first with nitrogen needs 3 electrons, so it sends 1, 2, 3 for sharing. Nitrogen sent 3 for sharing out of 5, and 2 left as we call lone pair. Here you see chlorine was having 7 outer shell, 1 short. So chlorine sends 1 for sharing. When chlorine sends 1 for sharing, still 6 electrons to be there in the outer shell. That we show as 6 crosses, 3 pair. So this is chlorine will do the same thing. Sends 1 and remains there 6 electrons. This is dot and cross diagram of nitrogen trichloride. I think this video class has made your dot and cross diagram problem very clear. And if you want to have this type of classes more with us, then stay with us. Thank you.